Welcome all. My name is Thomas Steenbergen, not Philippe. This is a more improvised talk because I literally heard this morning from the Linux Foundation. They asked me if I could talk, so I said like sure. I have many hats on, and if you see the next slide, you see why I can generally speak on all that stuff. I work on like strategic open source management. So that's basically think of in large organizations, how do you deal with open source at scale and at speed? Using it safely, efficiently, strategically. That's basically what I do. I've worked for various OSPOs in the past. I now do work for AboutCode, which is a non-profit that builds all kinds of tooling. I will get into minutes. But I'm also involved in several Linux Foundation projects. So if you have any other questions about tooling, about how SBOM standards, I can probably answer that. I'm also the European To-Do Group ambassador. How many in the room, maybe show of hands, how many in the room have heard from the To-Do Group? All right, then I should explain some. How many knows people these logos, or shall I explain? So To-Do Group is the working group under the Linux Foundation where corporations work together on like the topic of open source management. So open source is a very complex topic. There are many different facets, from security to licensing to engineering practices. And as we say to do, we say your OSPO, so open source program, your OSPO is not my OSPO. Every organization is different, therefore every management. So under the Linux Foundation, we have something called the To-Do Group, where we work together on like, hey, what have you tried? What works for you? What doesn't work for you? Then on the left-hand side, again, SPX is an SBOM standard, software bill of materials, so that's like your ingredient list. Phenols is kind of the same, well, roughly the same as To-Do, but more focused on financial services. So in banking, there are lots of specific regulations where I have fun stuff where I did some work for a bank and, well, GitHub was blocked. So how are you going to set up an open source community if github.com is blocked in all offices of the bank? I know how to do that. Open chain is kind of like trust in the supply chain. So, hey, how do I get my suppliers to deliver me right? How do I make sure that they manage open source correctly and give me all the right data? Open Source Toolkit is a tool that I'm one of the co-founders on. This is kind of like where we want to manage it open source scale. So I always do, okay, I need to do my policy. I have a policy where my corporation says, this is how we should do open source. How can I really do this? So we developed a system that's kind of an SCA tool combined with other stuff where we can do policy as code. So what we can do is we can really take a policy that the corporation want to do and actually write this out in code. And you as a developer can actually understand that. So it's not like that, oh, you have a scanner and you get lots of results, and as a developer, you have to figure out what to do. No, it actually tells you this is broken. And what it also does, it generates the artifacts that you need to comply with, for instance, like copyright licenses. So all the things that we needed as kind of an OSPO, we built our own tools for because they didn't exist on the market. I'm here for AboutCode. AboutCode is a non-profit that kind of works on open tools, open data, and open standards, basically for automation of your supply chain. So there is tooling to basically scan for copyright license. That's called scan code. Something you might have heard of is package URL. That's like a unique identifier for open source packages. That's now pretty much adopted industry-wide. Every SBOM standard, lots of security vendors have it. Well, that comes out of AboutCode. Then we have vulnerable code, which is an open source vulnerability database. You might be surprised, huh? Yeah, there are not really open source vulnerability databases where everything is really free. You can have there are lots of them that are proprietary, where you can use for free, but there's very little that's actually fully open. And especially if you look at open source projects that want to use pretty full stuff, this one. And Deja Code is kind of like the app on top to actually for legal people, product managers, or compliance folks to actually work with all the data that all the scan tools provide. So you can find more on our website and GitHub. So let's get into the fun stuff. Do people know this date? Okay, so we have some CRA folks, then I can go there. So then I can go a little bit faster on all the things. So yeah, we need to do things on this date from the CRA, and we're selling software. my view, you should never sell software, just give it away as open source and charge for other stuff. But unfortunately, the CRA doesn't let you get away with that stuff, because even if you give services around like open source, you're still on the hook. And let's say a vulnerability was just discovered in your software. So I have Umo here. My good friend Umo says like, hey, I found a vulnerability, Thomas. And I'm like, crap. Then I have to do things, because if Umo sends me a report, I have 24 hours to process basically and report it. Well, that's fine if you're a small company and you have very little income. So generally the organization that I work with, and I've worked with everything from public sector, defense, telecom, automotive for many years, we're not small companies. You're dealing with literally thousands of developers building hundreds of products. You need to do things at scale and speed. And that's where things generally kind of break down, because nobody really built stuff. Like, I know what the politicians want, and that actually was a good thing. But again, I work on the practical things, right? It's like, shit. And so you used to be able to just create a paper tiger where on paper we had a perfect policy and this is what it's supposed to work. Yeah, but it's not like that. We are using a lot of open source. Vulnerabilities are all the time. And you can't just show up like, oh, I have a paper process, this is how it's supposed to work, because it doesn't. It doesn't anymore. So, and the CRA is, I said, I'm pretty more familiar with it, so I can quite quickly. Just the highlight part. The CRA is kind of a big ouchie when you don't do things correctly. It's 15 million or 2.5 of your global revenue, and that's per incident. So, I will tell you the companies that I work for, but the amount of incidents that I was dealing with, even though this might be funny, I'm not a security person. I am an OSPO person. My job in the OSPO was basically, okay, we have a security vulnerability. You have the security team shouting all this stuff. Now comes the funny thing. There is a process on how to remediate it, but there's the number one problem already in most corporations. You want to have people guess what is the number one problem? You want me to go on a microphone? Okay. So what do you think is the number one problem when there is a security vulnerability in a large corporation?
Who is responsible?
Yeah. Who actually worked? Well, that's mostly we have a knock. So who actually wrote that software? Because most companies actually that I've worked with have no engineering standards. What I mean with engineering standards, one of the bits what you commonly see in the open source world is when you publish a package, there is generally an authors field and a link to the code repository. On the corporate side, bleh. So I have a binary here that somebody reported a vulnerability to, but first of all, who built that binary? Where in which part is the things in there? So you have to basically trace back all the way to the source code who actually freaking built this package and notify them. And I can tell you, a lot of the security teams that I work with, there's a frantic emailing of engineering managers like, who built this, who did this, and then people get called out of bed. And unfortunately for me, I most of the time work in the OSPO and I do compliance. So we review everything every review. So my phone would usually ring and they would be like, hey, we have this product, this and this and this. Do you happen to know who wrote the code? So this is why actually we invented a toolkit that resolves everything back to source code so that we have engineering standards so that every public package would know who published it. But this is very common in most organizations. It's always scrambling who actually wrote the code. And now you have to report within 3 days. So now a lot of companies are like, crap, we need to fix this. We need to start doing with this. But that's where things go wrong. And this is where, if you look at the CRA, it's everywhere. And because everything is changed, and it does exclude, so this is where I was helpful. You see there is like telecom, healthcare, and automotive is excluded. You know why? Because they already have legislation that basically asks us stuff. So I already worked on this before the CRA. So all the stuff that's in the CRA, I'm actually very comfortable with it because it's really nothing new. All the thing does is it expands the scope way further than where it used to be. But anyways, if you work, and I've done medical, I've done telecom, I've done automotive, it was already a requirement. You already had to do it. And then people are like, Well, we always make the joke about automotive-grade software, which is if you're in the automotive software, you know what the joke is there. It's very, very difficult. Because how are you going to do it when the SaaS is a significant part of your product? How are you going to get a SaaS provider to give you actually what's in there? And maybe that SaaS relies on other SaaSes. It's a very intransparent weave. And this is where kind of like my work comes in. As an OSPO, basically, we actually help the engineering teams actually understand these things and fix this. So it's not only making selection from open source from a technical perspective, but really look at the whole full picture at legal, technology, security, and all that other stuff. So yeah, I think we can skip this. But yeah, there's lots of CRA effects. CRA is worldwide, so it hurts like GDPR. It's everywhere. So let's look how we're going to do this. And I'm going to get this relatively quickly because I think most of the room knows it already, but this is basically what you have to do. So yeah, we have to track everything. What is used? That's a very simple statement. What would you say, like roughly you think how many open source packages an organization use? Numbers. Do you think an organization, let's say let's see how much we have a small, let's say a small company, let's say 200 employees. They have 3 products. How many open source components do you think that company uses? Yeah. Now, let's say we have a small company like Bosch. Only 400,000 employees. We happen to have one of those there. How many open source components do you think they have? Millions. So continuously tracking all third-party packages, and this third package is not just open source. It's also everything in between, what is source available, or whatever you call it, everything. So this is kind of the same as basically going to the supermarket where we have ingredient list, and there were no ingredient list, and the politician comes like, hey, I want to have an ingredient list, and you please do this in 2 years. I'm like, have you ever been to Walmart or Albert Heijn here? You know how many products they carry? Do you know how many ingredients are on this product? That's basically what the politicians are asking for us. Luckily for us, the more open source friendly you are, the more easier this is to do. And you're not alone. So this is where actually we work on in AboutCode. We basically build open source tools and open source data for that to say like, look, instead of everybody reinventing the wheel, and this is what we see a lot, is that people will keep buying commercial solutions and they expect them to magically fix everything. It's not. We as an open source community need to look at it and say like, no, we need open source solution for basically this whole open source management topic. If we don't fix things as a community. To be clear, I'm not saying that every open source maintainer needs to do things. I'm saying that we as consumers, if you're a consumer of open source, need to take the responsibility and go upstream and fix this. Don't go to a maintainer that says like, you have to do this. I'm an open source maintainer myself. I, on a regular basis, get emails from all kinds like, hey, we have to comply with the CRA or whatever legislation. And I get like PDF attachments with multiple pages. Can you please fill in? I always love the one, have you fought in the Second World War? Or are you currently have active relationship with North Korea? I'm always loving those. But yeah, those are in the form. I get it. I worked on the SPX SBOM, the security profile. The DoD came around and asked me if I could have about 1,800 fields to the SBOM standard, so that I would have all the data that they need. And I was like, no, we're not going to do this because no open source maintainer is going to fill in 1,800 fields for every open source package that they maintain. If you need this data, then you need to set up the infrastructure to get this data. You can essentially work with the community process, make sure that it's easier to obtain this data by making provenance traces in there. So make sure that we are working with the community, that it's easier to trace, hey, what package was included? What is the big problem is if you have an open source packages, from which sources was that being built? So those are the things that you can work on and that you get it easier to trace back. So yeah, again, the rest is pretty much obvious. Watch for known vulnerabilities. I always find this funny. And the security people never understand why I find this funny. I have friends that work for banks. And when they write a for loop today, that code gets shipped over to Bangladesh or to Philippines. And the next day, he gets a thing back and says, why did you use a for loop and not a while loop? So every line of code that he writes in this bank gets checked. But every piece of open source that they use is only checked for known vulnerabilities. Do you know what banking police do in this kind of situation, engineers? At night, they write an open source library, implements all the functionality that they need. Just write one statement, include statement. They get a thing, why did you include this open source library? Well, because this library did exactly what I needed. And it only gets checked for known vulnerabilities. So this is this weird, twisted way that I find like, yeah. Then we have to get, again, determine exploitability. This is another very big problem. How do you know something is actually exploitable? And are people familiar with the term rescoring? CVE rescoring? I will explain. So if you read actually the CVE stuff and all the CSS stuff, it basically like, yeah, this is what the original party says, like this is a high or critical. Most companies I work with have a policy that if it's a high and critical, you need to fix it within X amount of time. An understandable, yet incredibly stupid policy. Because why do I need to fix something that is a high and critical if it's in air-gapped internal software that has no connection to the internet? Can you explain why I need to fix this, drop everything that I'm doing for something that is completely freaking air-gapped? This is where, if you read the specs correctly, it says you need to rescore. So you need to look at your environment, look at what was reported, recalculate the math, and then you figure out like, hey, what was maybe a critical, because it's completely unexploitable, it now goes down to a low. Like 99.99% of the companies that I work with or any organization, they've never heard of this concept. And I'm just like, yeah. But now it comes to the fun thing where the law says you have to start reporting things. And now we get the fun stuff where now a lot of companies are like, crap, we actually have not so good processes for security if you really think about it. It kind of worked on paper. And now my screen hopefully doesn't die out. It kind of worked on paper, but now we have to report it to the government. And now comes the fun thing. If you give wrong data to the government, this will be public data. So your customers will also be able to see this data. What do you think your customers are going to do if you continuously report bogus vulnerability stuff? And remember, I don't know if you noticed, but whenever a company that I worked for, and whenever that supplier that had a high or critical, because of the stupid policies, a high or critical would cost the company tens of thousands of euros, because every development team would have to check if they were using that particular package. That is not cheap. Now you're going to send it to the government, and all the customers are going to know and check that stuff. So when I looked at this already, from our customers, like, this is going to be fun. So you have to get it right. You have to communicate correctly and give the right data. But the processes in most companies are completely not set up. Yeah, they have security teams that can look at it, but security don't know all the details. And none of these processes are set up to operate at scale and at speed. A lot of manual, a lot of not automated. Yeah, the detection is all automated, but actually is something correct? Because most companies, as I said, they have no engineering standard. They lack context. They don't know when a particular software product, is this internal? Is this an SaaS? Is this SDK? All those kind of metadata, the context of that piece of software is usually not tracked. Whenever I ask companies, do you have a software catalog? They usually look, yeah, we have a very software catalog for the products we sell. Now, I mean a software catalog of actually the software that you built internally. Every component that you built internally, which development team builds it, how is it built, where is it stored? Very few have that. So let's go do things. We're going to look at SBOMs. And I said, I worked on SPX, SBOM. I also did some work in PsychoDX. Everybody now start generating SBOMs. We're currently in the phase, what I still call the any SBOM phase. Everybody produces SBOM. The majority of them is garbage, which is a big problem for me because I automate on the data that is in there. And if you give me garbage in, my system produces garbage out. The problem is if I produce garbage out and I have to report that garbage out to the government, I have a problem. So this is where basically we have an issue. And that's where I've been working on fixing it and cleaning things up. And this is why when we talked in the AboutCode project, we need something that's open source, fully open data, so we can take all the input about projects and basically share this publicly. And as a community say like, hey, this scanner detected something, but it's actually bogus, it's a misfire, let's go. Or actually, yes, there is a known pattern from this thing because this copy was copied over from somewhere else, but actually in the context of this particular open source project, this is not exploitable. So lots of times what you see is that a vulnerability is reported to a particular piece of code, but that piece of code has been forked or copied over, snipped over in multiple other open source projects. But in the other fork, there may be a different API where that endpoint is not callable. Why can we not record this together and basically say like, yes, the same code is present, in this context it's exploitable, but in the forked version it's not exploitable. Actually, funny enough, it's usually the other way around, because the original upstream usually fixes things, and the forks are usually behind. Do people still remember Log4j? Do you want to know how many Log4js are still exploitable in the internets? Depending who you ask, it's anywhere between 3,000 to 6,000. Different vendors have different answers, but yeah. So what happened is if you look at the reporting for Log4j, it's reported to the original library. But guess what we do in open source land? We fork stuff. So all of these forks are no known vulnerabilities are reported against these forks, which blows my mind. I was like, hang on, but I myself, and I'm not a Java person, I knew this thing was forked here and here and here. Why? Because my scanner literally in the name says Log4j. So I knew it was there, but none of the security vulnerabilities advisories record the other packages. So it still is used. So let's track all these things. Again, this is where I said before, you need to actually look at things in context. You need to get a reliable feed. And this is where you said, like, look, the current system, as you look at it, was kind of built for closed source software. But if you really, our software world is no longer closed source. The majority of software is open source. Why are we still using a mechanism that was built for closed source where, no, I don't want to share with you, this is my precious, where everything is open? Why don't we build a new system that, and so this is where it's actually good, where I don't know if people are familiar with like OSV, where Google started doing a lot of work to say, hey, let's share this open. But Google OSV only does such a thing. They only do certain ecosystems. They might not do what you need. And this is where like we really need to go to a more community-driven solution and really be able to look at all the things in the open. Open source is open. We should also be open about vulnerabilities. Because, so, again, I'm going to skip a little bit ahead on all the stuff that you need to do, because there's lots of different things you have to do. Because vulnerabilities are everywhere. And this is where I usually see, yeah, we check things when code is built. And I'm like, yeah, are you also scanning when you pull in open source, say, via your Artifactory? And they're like, what do you mean? Yeah. I know you're scanning at build in your CI/CD pipeline, but are you also checking in for things that is being pulled into your Artifactory that is just literally being pulled in and being deployed? So it is not. It doesn't even touch your code. It is just written in. I've seen so many things where we had stuff for our server deployment, which was ready-made code, it was just dumped on our Artifactory. It never touched any of our development teams, and our operations team was like, yeah, we know that on all of our machines, we need to have these open source packages installed. So we dump it in our Artifactory, and we directly write it to the operating system of all our engineers, so they don't have to do installation stuff. None of that was being checked, but it was included in every product because basically it was available on the system, so it was being pulled in automatically. And so what I generally also see is the monitoring cycle on looking everything. So a lot of development teams, they're very much living in the now. Yeah, but what about like the release from a half year ago or 3 years ago? Oh no, our customers just need to upgrade. Yeah, but if you're like me, familiar with the enterprise upgrade cycles, most of the time the customers were at least 6 months to a year behind with updating and all the others, especially if there were small enterprise components. So it's like you should really look forward. So this is like a very public thing. Do we want to go into there? And really the whole system is broken to the point that if you really want to know if something is exploitable, you should look at the CV data and you should look how often the thing for you to determine something exploitable, you would think as a developer, hang on, you would just put in a link to the GitHub repository with like a nice link says, hey, from line 4 to line 32 is the code that is exploitable and in this condition. Start having a look at what's being reported. It's all free-form text. Then we're also dealing with, I don't know if you've seen from Daniel Steenbergen, we are dealing now with a lot of AI slop. So people in bug bounties making things that look very credible until your people were then looking at it like, no, this is like complete utter gibberish. Again, everything was designed for a closed source system with lots of free-form text. Ideally, what you want to have is, oh, there's a vulnerability, it's known, the upstream maintainer has looked at it, and they add exactly like, these versions are vulnerable, this is the code that we're dealing with. So once you know exactly the code that we're dealing with, you can use several programs to basically determine whether your code has a path to that particular code. Most CVs don't. And this is where you see the numbers, it gets horrible and horrible. Determining if something is exploitable is actually, you're talking about hours per engineering team being spent on determining this. And yes, there are lots of magical tool solutions that come like, we can figure this out for you. My experience is they don't always. They work in simple scenarios, but most software that I look at is not simple. It's highly advanced, complex software where also due to historical reasons, things got duct taped together. There's lots of technical debt. So it is not a clean, hello world where it's really easy to do the end-to-end traceable. It's one system to the other system, then there's a network dependency, so you can't really do this. Yes, people are working on this. CAF is very helpful. EPSS is very helpful. Things are getting better, but it's not proper. So what does it really look for? And that's where I look for, purely look from looking at behavior of people. What we see is a lot of time, we see what I call notify and ignore workflows. So developer is forced to use a particular tool in their CI/CD. You have vulnerability, boom. Okay. When they just start out new in a job, they're like, oh, I'm the youngest, I'm supposed to research that. When they're 6 months in the job and every day they get 3 or 4 notifications and they already, developers are, with the whole shift left movement, they have to do more and more and more and more, they're just like, oh, fuck it, ignore. This doesn't really look plausible, ignore. So what you in reality get for a lot of these tools, the scanners, I'm like, oh, our tool can detect anything. Yeah, no, that's not the problem. Developers are overloaded by notifications. So what is the natural behavior? Oh, I have to have targets. I have to look at so many notifications. Nobody checks the notifications in depth. Nowhere, all those notifications never have like, oh, a second pair of eye has to review that the thing was properly reviewed. It's usually a button, ignore. So what does the developer do? I need to hit my targets. Ignore, 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 ignore. Has the problem gone away? No, the problem is still there. It's just the developer had a target to basically release the software. The tool gave notifications. Well, there's the fastest way to fix the tool is just click the ignore button. It's the first thing all developers look for. Where is the ignore button? And this is where me as an open source person was looking at and I was like, no, stop. Go back. Maybe we should stop overflowing developers with notifications and actually look at what things need to be done centrally as a team-based security team. So look at which notifications are used everywhere. What notification, because of the context, remember air-gapped or maybe it's alpha software, shouldn't be sent at all to the team at all. Because why would you send this high critical notification for stuff that's air-gapped? It's irrelevant. Just don't send a notification. Only send a notification if you really need them to fix something. Because what you otherwise get is every team gets overloaded. This is how most vendors like, look how much my tool detects. And everything is red, so many vulnerability. And then I usually start building it down. That's why I get in. What is actually applicable? And then the 9 criticals, none of it applicable. The 23 that were also in the middle, all gone. So when you really start looking at context, and that is what I said, most of them, and everybody does this information over and over. Stop doing that. So this is how I generally look at things. And this is funny because this overlaps with the, it overlaps with the CRA. If you read the CRA itself, it says we need to make risk-driven decisions. And usually lots of risk people, like lots of marketers, I am much more practical. I actually look at it, so okay, so we need to make risk-driven decisions. We need to have a product catalog, so we know what we ship to customers. What are the contracts that we sign with these customers? What type of customers are they? Are we shipping to, say, the Department of Defense? Or are we shipping to a small corner shop? What is the impact? What are the contracts that are being signed? What is the impact stuff? Then underneath of that, on my product catalog, I want to have a software catalog. I want to know every component that basically went there. If I talk to executives, I'm basically saying like, hey, imagine a salami sausage. What the government is now requiring, I need to know every freaking pig that went in there. We currently don't have the data. If you look at the food label of a salami sausage, it says usually, if you have good ones, it says 98% pork meat. Yeah, but which porks? Which were included? That's what the government is now asking for the stuff. And this is where internally you should know exactly how does this break down. And then you need to work together with your suppliers for them to do exactly. So this is why I'm involved with like Open Chain. It's not just only a question within your own organization. You need to also work with all of your suppliers. Everybody in the chain needs to start providing accurate data. Then I also have an operational catalog because I actually want to know where is stuff actually being deployed. You might want to notice, well, guess what? Legislation across the world is different. So I used to work for a company that deployed in Europe, Americas, Korea, and China. I can tell you that the Chinese law and the Korean law regarding cybersecurity is slightly different than in Europe. You need to know that stuff. You need to know where things are being deployed. And also, if you have the deployment catalog, this is very useful. When we run it in our Kubernetes cluster, I would know from the deployment catalog, for instance, if a particular service had an external-facing IP address. Hey, if it has an external-facing IP address, it's accessible, maybe accessible for the world. That gives me risk input. Whilst if I can see from my deployment catalog, it's like, oh, this runs in our internal data centers. Again, I know from my deployment catalog it runs only in our internal data centers, nothing else touches it. Then if there's a high or critical reported, the likely chance that the network exploitable is much lower. Now the question is, do your organization have such a setup? I doubt not. Very few in Europe that I have seen have really a setup where they actually keep track of all this stuff and really look at the whole context. But this is a completely different thing. So now you're moving away from security and you're actually looking at what? Engineering standards. You're looking at how you do your engineering and putting it properly in a way that you have all the data that you actually need. And I haven't even talked about like how your local registries work when you copy things over. There's so many other things that basically generally the systems are not designed, and the security people are generally saying like, this is not our cup of tea. This is the point from the people that run our GitLab or whatever. It's like, and they look at it, it's like, no, this is not our point. Like, this is generally where I see OSPOs coming in and they say like, no, let's just coordinate that this happens properly. Now let's send some reports. Yeah. This is still a fun thing. This is not yet clear at this moment. So yes, reporting is required. The format, how you need to do it, what level. We had a whole discussion. I remember one of the discussions where it said like, oh yeah, you only, when they ask for an SBOM, for instance, you only have to report your direct dependencies. And I'm just like, I know people are lobbying for this because it makes your life easier, but it's kind of pointless to just report your direct dependencies. Because you know what the developer is then going to do? Remove a direct dependency. So like, hey, instead of making a direct dependency, I'm just going to put this artificial package in between and all my other stuff, I'm just going to put one layer deeper. And it's like, no, we have no open source dependencies. I just depend on this one internal other open source package. And you think like, Thomas, you're very... No, remember, I've worked with hundreds of engineers in tens of companies. Especially when I was in Germany, you would not be surprised because of Works Council how many engineers are active at night. And no, I didn't report this to the company for legal reasons because then you get into the problem with Works Council stuff. But for fun and giggles, I did run the numbers and it's scary how many developers are working on stuff. And when you start looking at where they are working on, it's usually things for the work that they can't get done in the regular framework. So they do this open source in their private time. So I have to see if I'm on time. Yes. So let's do things differently. So what if? And I have to go a little bit further. So let's stop the nonsense and let's work on this together. That's basically the nutshell. This is what we're doing. We're basically building, as I said, all kinds of tools to help with this whole saga. We also want to do this in a federated way. So this is the problem that I see a lot of times. There's one entity that controls everything. I'm like, yeah, why? We know how to build federated systems. There's no need for everything. Yes, I know it's convenient, and we still will offer it from the foundation work where we are one center, but that's just for like open source projects to make it easier for them to just give a REST API where they can query things. But the rest of the world, I think basically governments should have their own federated nodes of vulnerability data and scan data. So there is not a central point. Think of just about digital resilience. Now, I don't know if people know, but earlier, was it this year or last year, the NVD had some financial problems and whether they could get funded. Why, as a world, do we all depend on the American government? From a pure principle perspective, it shouldn't be that difficult to copy the data and make an own process to maintain it yourself. But
See how bad the EUPD's API is?
I know. Don't get me started. We could have a whole workshop on that. Quickly, so. And I will not because we're running out of time, but so luckily we are from AboutCode. We are getting money from the European Commission to actually work on all this stuff. Again, open source is not for free. Our lovely developers also have to eat. So luckily we have the European Commission help out. So one of them maybe highlight is for Octet. Also European Commission. This is really to help SMEs because there are plenty of companies in the EU that do build digital projects, but they're not a Bosch, they're not a Siemens, they're really, really tiny. They do not have the manpower. And for this, when I was working in the automotive industry, in the supply chain, this is why we loved open source. Because we said, like, how do I get my entire supply chain cleaned up? Remember, I can clean up my own house, but about 30 to 40% of my software came from external vendors. And they had external vendors, and they had external vendors. You cannot all say like, hey, we're buying this big commercial tool, and everybody in my supply chain has to use it. First, you know why you can't say that? You get in trouble with the law. You cannot force it as a customer. So this is why open source is the right way for us forward. And this is why it's lovely that the European Commission helps of building this kind of solutions. So what is next? We have so many things that we're working on. We have really fun things that we're scanning all of software heritage, so that we know for all the code that's been archived, what is the licensing. We are now currently working on building a huge data set for building up we're building up a new foundation to build the data set, so that we can actually have a public available set that anybody can use. What are the licenses from open source software? How it was being built? Are there known security vulnerabilities? And the lovely thing is it's actually being picked up. I said all the things that the AboutCode does, it ends up everywhere. We don't always get credit, but we're fine with that. But you see, Perl was adopted everywhere. Scan code is used everywhere under the hood as a copyrighted license scanner. So this is always funny. Quickly, some lessons learned from my lots of things. Again, basic things. I know for me, and this sounds might weird from a for security talk. Start looking at engineering standards. The majority of the security stuff that you're dealing with can be fixed by engineering standards. So make sure that your own package have the right name. Make sure that all of the packages that you write have a code repository URL, so that when a package is packaged, when published, you know like, hey, this binary belongs to that source code. So you can actually trace things down. Have a policy on open source selection. I am a very much open source guy, but when I was working as an OSPAL, we had an SDK team. That was 19 different teams, really big project. And they were roughly 70 open source dependencies. They were all bulking on like, oh, all this open source dependencies, we need to do all this compliance and all that other stuff. And then I looked at it like, but guys, Why don't do a smarter setup? They were using Maven. Maven has a thing where you can combine shared open source libraries together. So what we did, we made a shared BOM where we put all the shared open source dependencies from all those 19 teams. And they were only then responsible for the open source dependencies that were unique to them. Everything that was shared, and if you look at most corporate stacks, they share a lot of the same open source. Change your setup. And then we had a QA team doing the checks and compliance stuff, and the rest of the SK team, they only had the 3 or 4 teams. That's it. Any questions?
Yeah. I'm sorry that this is less of a question and more of a comment, but with regards to the CRA, you're mistaken about the standard of exploitability versus known actively exploited. The notification requirements, specifically the 24 hours, specifically kick in when you have an actively exploited vulnerability. The known exploitability is in a different article. You can't launch software with known exploitable vulnerabilities. So you do not need to notify or analyze, notify within 24 hours for vulnerabilities that are merely exploitable.
That's true. But also I look at the context. What is in the CRA and what is common in the industry? So there are things that are required in the CRA, but there's also, again, I worked in automotive where there's lots of contracts being written. And they're slightly different worded. And they work in the first way.
Very true. But the CRA is very, very harsh, of very large fines, very tight deadlines. And
Yeah.
it does relate specifically to actively exploited. And it's quite clearly defined in Article 14 and in the call upon exactly what the actively exploited means.
Yeah. So as I said, for me, it's standard list. Yes, it's what law says. And then I know what is industry standard. What will actually happen. Because basically companies don't make that thing. So yeah, for the reporting requirement, it's easier. So it's a less of a burden. But again, how do you, again, we go signal what's actually exploited. Okay, how do I know for sure that it is not in my environment, my different setup? Because when I looked at our scan data, what we get from like security stuff, there's a good chance it might be exploited. So, and like for actually figuring, this is for me what I found tricky, for me to actually figure it out takes me longer now than I actually have time for under the law. And this is where it's like, oh crap, yeah, we have to report it. Because I'm rather be cautious and over-report it than that I don't report it.
Well, okay, so I completely agree with you about the practice of it and what we should be doing. But as far as the under the law parts,
Yeah.
what it means for something to be known actively exploited means that you have to have an actual end user whose product that you have placed on the market is compromised. So it's not that you don't have to do this kind of investigation to determine whether the law is triggered. You only have to know whether you have a verifiable report of an actual product in the field that has been exploited.
But let's take it offline because I think we have to make space for the next one.